Okay, this is 7.2, factoring trinomials. And remember, a trinomial is just something that has, it's an equation, or in this case an expression that has three terms. So remember, terms are separated by plus and minus signs. So we've got x squared here is a term, bx is a term, and c is a term. So that makes it a trinomial since it has three terms. You'll also hear this called quadratic equations. And what makes it a quadratic equation is because it has an x squared in it, not just x's. It has an x squared in it. So we'll be solving, eventually at the end of this chapter, we'll be solving these quadratic equations and graphing those. And I'll show you how those look. But factoring is just the opposite of distributing. So basically, we're going to take something that's already been distributed and put it back in the factored form. So, for instance, when we factor number 1 here, we're going to end up having two parentheses where we've got something in those parentheses that we could distribute out and get x squared plus 7x plus 10. So how you factor is, the first thing that you want to do is identify three important letters here, and that is the A, the B, and the C of this quadratic. The A is always the coefficient in front of x squared. So remember, coefficient means a number in front of. So in this case, the number in front of x squared is 1. So our A is 1. That's going to be important to us in a minute. And then B is the coefficient in front of the x. So in this case, our B is 7. And then C is just the constant. That's the number that doesn't have a variable that follows it. So in this case, the C is 10. So first, you always want to identify your A, B, and C of your quadratic. Then the next thing that you want to do is you want to multiply A times C. So we want to multiply A times C. So A times C is 1 times 10, which is 10. So what we're going to do is find factors of 10. Now, factors mean we want multiplication problems that equal 10. And the only two multiplication problems that equal 10, actually there's 4. 1 times 10, 2 times 5, and then you could also do negative 1 times negative 10, and negative 2 times negative 5. All 4 of those would equal positive 10. And sometimes we'll need the negatives, but I'll show you in what case you might need those. Now, we want the multiplication problems that equal 10, but at the same time, those same numbers need to add to be our B term. So whatever our B term is. So this time, we want those numbers to add to be 7. So if we look at 1 plus 10, that does not equal 7. That equals 11. 2 plus 5 does equal 7. So 2 and 5 are what we're going to use because they multiply to be 10, which was A times C, and those same two numbers add to be positive 7. And these signs are going to be really, really important, but this time they were both positive. So our factors, or the factoring of this quadratic equation, what you do is you put your x's in the front, and then you put your factors, the numbers that you found that add to be, or multiply to be 10 and add to be 7, you put those next. So we've got a positive 2 and a positive 5. And that's our answer. X plus 2 times the quantity x plus 5 is the same thing as x squared plus 7x plus 10. Now let me show you how you could check that just to make sure. And this is always a good idea, especially if you're on a multiple choice test or just taking any test in general. You could take your answer, double distribute it and make sure that it works out to be what the original problem was. So if I double distribute this, x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 2 times 5 is 10. And then the terms in the middle are like terms, so those get added. So sure enough, I've got x squared plus 7x plus 10, which is what we started with. So again, the answer that you would type in Math Lab would be x plus 2 and x plus 5. In parentheses, both of those. Okay, let's look at our next problem here, which is going to be problem number 2. So again, we're going to start by multiplying a times c. In this case, our a, the number in front of x squared is 1. Our b, and be careful here, is negative 10. And our c is positive 9. So we want factors of a times c, so 1 times 9, which is 9. So we want multiplication problems that equal 9. But at the same time, those multiplication problems need to add to be negative 10. So I always start by writing down multiplication problems that would equal positive 9. So 1 times 9 is the easiest. But when I add 1 and 9, it doesn't equal negative 10. It equals positive 10. So that one's not going to work. 3 times 3 is the other one. That's 9. But 3 plus 3 is 6, and that's not going to work. So here's an example where we might need negatives. Negative 1 times negative 9 is still positive 9. And this time when we add those numbers together, negative 1 plus negative 9, that will equal negative 10. So this is what we want to use here. We want to use negative 1 and negative 9 as our factors. So again, factors are in 2 parentheses. You always put your x's in the front, and then the numbers that you found that multiply together to be positive 9, but at the same time add together to be negative 10. So negative 1, negative 9. Okay, let's look at number 4. So our A is 1, our B is negative 1, and our C is negative 2. So A times C is 1 times negative 2, which is negative 2. So we want multiplication problems that equal negative 2. And our sum needs to be this one, B, which is negative 1. So there's only one multiplication problem that equals 2, 1 times 2, but we need it to equal negative 2. So we could do 1 times negative 2, that's negative 2. Or we could do negative 1 times positive 2, which is also negative 2. But we need to find which one of those equal negative 1 when we add. So 1 plus negative 2 does equal negative 1. So this one is the one that we want to use. If we did the other one, negative 1 plus positive 2, that would equal positive 1. So that one does not work. So our factors, in parentheses, x in the front, and then the numbers that we found to work for both were positive 1 and negative 2. Alright, we move on to our next slide here. And our homework problem number 6, the only reason this one's a little bit different is I just wanted you to realize that this is not in the right order. This is not in ABC order here. So we really should put that in ABC order before we do anything else here. So we'll start by putting our t squared first. Then our 6t, and then our negative 16. So that's in ABC order now. So we know that our a is 1, because that's the number in front of the t squared. Our b is 6, and our c is negative 16. Okay, so we want to do a times c first. So that'll be 1 times negative 16, which is negative 16. And then we want to add those numbers together to get the b term, which in this case is 6. So our b is positive 6. Okay, so we need multiplication problems that add to be, or multiplication problems that equal negative 16 but add to be 6. So don't make this difficult. We want to start with 1 always. So one thing that will kind of help you to know whether your smaller number should be positive in your, because we know a positive times a negative is going to be a negative either. But our smaller number should be the negative, and our bigger number should be the positive, because when I add them, I want them to be positive 6. So negative 1 times 16 is negative 16, but when I add those together, it equals positive 15. See, if I had switched those and made my negative the bigger number, then when I add them, I'm going to get a negative. And I know when I add them, I need a positive. So that might help us maybe not have to write so many multiplication problems down. So I started with 1. I know that 2 goes into 16, so 2 times negative 8 would be negative 16. And when I add 2 plus negative 8, I get negative 6. And I just did what I told you not to do, which was to make your bigger number positive. So I'll switch those two. Negative 2 times positive 8 is negative 16. And negative 2 plus positive 8 is positive 6. So this row is the right one. The negative 2 and the 8 equal negative 16 when we multiply, and equals 6 when we add. So our factors, now this time they're using t instead of x. So on Math Lab, just make sure you use the whatever letter they use. So we found that negative 2 and positive 8 were the two numbers that would work. And again, don't forget that you can distribute this and make sure it works. T times t is t squared. T times 8 is 8t. Negative 2 times t is negative 2t. And negative 2 times 8 is negative 16. Then in the middle, you've got your like terms. So it would be t squared. Positive 8 minus 2 is positive 6t. And then negative 16. So it does equal what we started with up here. So the correct answer is t minus 2 times t plus 8. Now that should get you through practice problems 1 through 7. Now when you get to practice problem number 8, they become a little bit different, because if you notice there's a number in front of x squared. So far all the numbers that we've used in front of x squared have just been 1s. Now the good news is we can do what we learned in lesson 1 to help kind of simplify this problem before we have to factor it. And the way we do that is we look at the three terms, the a, the b, and the c, and we see if there's a greatest common factor. Is there anything that goes into 3x squared, 27x, and 42 that we can factor out? And And the answer is that 3 goes into all 3 of those. So we're going to divide each one of those by 3. And what we divide by goes out in front. And then we just divide that and see what's left. So 3x squared divided by 3. These 3's cancel, and I've got an x squared left. 27x divided by 3 is 9x. Don't forget your x there. And then 42 divided by 3 is 14. So now I've factored out my GCF, but I still have to factor the trinomial that's left out here. So I need to figure out the trinomial that's left. I want to figure out what my a, b, and c are. So the a is that number in front of x squared, which is 1. The b is the number in front of x, 9. And the c is 14. So I want factors of a times c, which is 14. And the sum needs to be the b term, which in this case is 9. So 1 times 14 is 14. But 1 plus 14 is 15 and not 9. So that's not going to work. Then I know 2 times 7 is 14. And 2 plus 7 is 9. So 2 and 7 are going to be my factors. So I'll write this. Now the one thing I don't want to forget on this one is there's got to be a 3 on the outside of even what I factor down here. So I'll write that down here. So we're going to put our 3 first. And then we're going to put our 2 parentheses. So the x's go first, and then a positive 2 and a positive 7. If we have not put that 3 there, when we distribute this out, it would be x squared plus 7x plus 2x plus 14, and that doesn't equal what we started with. But when I multiply that answer by 3, this simplifies. X squared plus 9x plus 14. But then when I multiply it by 3 and distribute that 3 out, I do get what I started with. 3x squared plus 27x plus 14. So this part is the answer here, but it does need to have that 3 in it. So number 11 maybe one of the harder ones on here, but again, we want to just factor out the greatest common factor. So I know that 4, 20, and 24, that 4 goes into all of those. But this time they also have some t's in common. All 3 of these have at least one t. Actually, all 3 of these have at least 3 t's involved. So I'm going to divide each of these by 4t to the third. And if they all have a t, basically they'll all have the lowest number in there. So when I divide this one, the 4's cancel, and t to the 5th divided by t to the third is t to the second. So remember, what we divide by goes out in front, and then we're going to put what's left in the parentheses. So t to the 5th divided by t to the third is t to the second. Remember, we subtract exponents here. Then I've got negative 20 divided by 4, which is negative 5. And t to the 4th divided by t to the third is t to the first, but I don't have to put the first power. On this one, t to the third and t to the third cancel. So I've just got 24 divided by 4, which is positive 6. Now this part is the quadratic. It has a t squared in it. So we're going to try to factor that further. So I want factors of our a times c, which in this case is 1 times 6, which is 6. The sum of the factors need to be negative 5, the b term. So multiplication that equals positive 6 but adds to be negative 5. The only way you can get a positive when you multiply and a negative when you add is for both of your multiplication factors to be negative. So like negative 1 times negative 6 is going to be positive 6, and negative 1 plus negative 6 is going to be negative 7. So I was able to multiply and get a positive, but add and get a negative, but that one didn't work because it wasn't negative 5. So let's try another one. 2 goes into 6 3 times, and negative 2 plus negative 3 is negative 5. So we found our factors here. It's negative 2 and negative 3. So we'll go back up here, and we'll make sure that we drop the 4t to the third that we factored out earlier. And then we should put a t in the front, and then negative 2 and negative 3 were the factors that we found that multiply to be negative 6, or positive 6, and add to be negative 5. Last problem that I want to show you is number 15, and again we're going to have to factor out something here because we've got a number in front of the t squared. The reason I wanted to show you this one was because the number in front of the t squared is a negative number, and you never want your a to be negative. So even if it was just negative 1, we would divide everything by that negative 1. So in this case, we're going to divide everything by negative 16. Get that factored out of there, because 16 does go into all of those. Now we're going to learn in tomorrow's lesson that sometimes you won't be able to divide, and I'll show you what to do. But today everything should divide and give you a nice problem to work with. So the negative 16 that we divide by goes out in front, and these cancel here, so I've got t squared. And then 32 divided by negative 16 is negative 2 with a t left. 48 divided by negative 16 is a negative 3. So I want to do a times c, which is 1 times negative 3, which is negative 3. And the sum needs to be our b term, which is negative 2. So multiplication that equals negative 3 is going to be 1 times negative 3, and then 1 plus negative 3 is negative 2. So we have found our factors. So drop the negative 16 down, put your 2 parentheses, t's in the front, and then a positive 1 and a negative 3. And this is the answer, the factored form of this quadratic.